Hello everyone, good morning. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Chemical Equilibrium, and in this session we are going to learn about the relation between vapor density and degree of dissociation. Okay, degree of dissociation. So generally this is applicable for the reaction in which reactants and products are in gaseous state. Gaseous state. Right? We are deriving a formula. In deriving the formula between degree of dissociation and vapor density, let's start the derivation. Okay. So in the derivation, what was taken? Reactant and products. Let us take a reactant B, A, and product B, B. Okay. So now I am taking 1 mole of A gives you Y moles of B. Are you finding this? Right? What does this represent here? 1 mole of A on reaction produces what is that? Y moles of B. Y moles of B. The meaning of this reaction. Okay, they are in gaseous state. Let us take. Looking at the reaction or equation, we can say that 1 mole of A on reaction gives you Y mole of B. For this, if I ask you, if 2 moles of A are reacted, 2 moles of A are reacted on reaction produces how many moles of B? 1 mole is producing Y, 2 moles is producing 2 Y moles. Are you getting? 1 mole of A on reaction produces Y. Then 2 mole produces 2Y. If I give you 3 moles produces 3 mole of A on reaction gives how many moles of B? 3Y moles of B. 3Y moles of B. Did you understand? So here this point is important. 1 mole of A is producing how many moles of B? Y moles of B. This point is important. Okay. Next, for this reaction, I am taking as let X be the degree of dissociation. What is that? Let X be the degree of dissociation. If X is the degree of dissociation, at time t is equal to 0, reaction has not started. Let me take it as 1 mole of A. 1 mole of A. So how much is completed? At equilibrium, X is completed. As X is the degree of dissociation, it has dissociated, X moles is dissociated. As it is 1 we have taken directly, let X be the number of moles dissociated. How many formed? What is formed? A completed, Y is formed. How many moles of Y is formed? Y. Okay. X into Y is formed. X into Y. 1 mole if it is dissociated, how many moles are formed? Y moles. If I say you X moles dissociated, if X moles of A on reaction gives how much? X into Y moles of B. Gives you X into Y moles of B. Before 2 mole, 2 into Y, 3 mole, 3 into Y. X moles, X into Y. Right? Simple thing. Then at equilibrium, what is the number of moles of A? 1 initially present, 1 minus X. What is the number of moles of B present? X into Y. Okay. Total moles present. Total number of moles at equilibrium. Number of moles of A and number of moles of B. See, this container is containing both what and what? A is present as well as B is present. Total number of moles means you have to count the number of moles of A and the number of moles of B. That means 1 minus X is the number of moles of A and XY is the number of moles of B. Okay, if I take this can also be written as, if I take X as common, X is equal to Y minus 1 plus 1. So I can write this in this way also. X into Y, XY. Okay. X into minus 1 minus X plus 1. The same can be written in this way. So total number of moles at equilibrium is X into Y minus 1 plus 1. Okay. Now let me take this is let the volume occupied by 1 mole of A of gas A before dissociation, which is our before dissociation. So before dissociation, let it be volume B, 1 mole occupying volume B. Then volume occupied by how many moles? X into Y minus 1 plus 1 moles of gas, that is what? After dissociation. After dissociation is, see, 1 mole occupying V volume. These many moles will occupy how much volume? X into how much? X into Y minus 1 plus 1 into V. Simply understanding, 1 mole occupies V volume, X into Y minus 1 plus 1 moles occupy how much volume? How much volume? X into Y minus 1 plus 1 into V. That is what we have written. Okay. Next, let the density, or as it is in the gaseous form, directly I am writing, let the vapor density before dissociation. Before dissociation be D, capital D. Let the vapor density, who is present in the container before dissociation? Only who is present? Only A is present. After dissociation, both A and B are present. Before dissociation only A is present. After dissociation, both the A and B are present, right? So let the vapor density before dissociation be d, and density, we know that density is equal to what? Density is equal to mass by volume. Mass by volume, which is equal to mass by V. Mass by V. Next, let the vapor density of mixture of gases after dissociation. What is that? After dissociation. Be D. What is this? D. D can be written as mass by volume. Now volume is how much? Already we have discussed. What is this? X into y minus 1 plus 1 into V. Okay. Then if I divide d by d is equal to mass by volume V by mass by x into y minus 1, okay, plus 1 into V. V gets cancelled. Mass also gets cancelled. Why the mass must be cancelled? Why mass must be cancelled? See, this is container. This is container. Initially, what is taken? A is taken. After dissociation, what are present? A and B are present. Okay, both A and B are present. And we know, according to law of conservation of mass before dissociation, before reaction is equal to mass after reaction. This is according to law of conservation of mass. So mass before dissociation is equal to mass after dissociation. So then what do I get? What do I get? The formula d by d is equal to, okay, this goes up, x into y minus 1, okay, plus 1. This is the formula. So on this formula we are asked questions. Then if 1 comes this side, then what do I write? D by d minus 1 is equal to x into y minus 1. Then I can write x is equal to d minus d by d into y minus 1. Okay. So what is x? X is degree of dissociation. What is capital D? Vapor density before dissociation. What is small d? Vapor density of mixture after dissociation. What is y? Y is number of moles of the products formed when 1 mole of the reactant dissociates. So what is y? Number of moles of product formed when 1 mole of reactant reacts. Okay. What is x? Degree of dissociation. Already we have written that. So what is the formula? D minus d by d into y minus 1. This is the formula. So based on this formula, we are asked questions, right? So this is all derivation what I have derived. Here is printed. So x is equal to d minus d by d into y minus 1. And there is another relation that so molecular weight theoretical value is equal to capital D into D before dissociation. After dissociation, abnormal molecular weight is equal to D into D. So overall, vapor density into 2 is equal to molecular weight. What is that? Molecular weight is equal to 2 into vapor density. This formula we need to remember. So another way it is given. instead of Y, we have taken N. So here N, that's it. So where D is initial vapor density of A, D is vapor density of equilibrium mixture. So overall, what formula we need to remember? The formula which we need to remember is D by D is equal to, what is that? Alpha into n minus 1 plus 1. This is one formula which we need to remember. Another formula is d by d minus 1 is equal to alpha into n minus 1. What is n? We will see. So alpha is equal to d minus d by d into n minus 1, where n is number of moles of product formed when 1 mole of reactant reacts. Okay, reacted. So let us solve a problem on this. Okay. So here is the problem, you see. Calculate the vapor density of phosphine at 300 Kelvin and 2.5 atmosphere when it shows 40% dissociation to attain equilibrium. So first thing is phosphine. Already given reaction. What is that reaction? 4pH3 gives rise to P4 plus 6H2. This is the reaction. All are in gaseous state, you see. So what is asked? Vapor density of phosphine when it is 40% dissociated. 40% dissociated. What is this 40%? Percentage of degree of dissociation. What is this? Percentage of degree of dissociation. That means percentage of alpha is equal to 40%. If I want to know alpha, then what I want to do? 40 by 100, that is equal to 0.4. So if you want to convert percentage of alpha into alpha, then you need to divide that percentage with 100 so that we get the alpha. Okay. And we can apply the formula. What formula we can apply? The formula is that d minus d by d is equal to d into n minus 1 alpha is equal. This is the formula. What is n here? N is number of moles of the products formed when 1 mole of the reactant reacted. 1 mole of the reactant reacted. But here 4 moles given. 4 moles of phosphine given. So let us convert 4 moles into 1 mole. If you want to convert, then divide the complete equation by 4. So 4 by 4 pH3 is equal to, okay, 1 by 4 P4 plus 6 by 4 H2. Then 1 mole of pH3 gives rise to 1 by 4 mole of P4 plus 3 by 2 H2. Now what is N? N is equal to 1 by 4 plus 3 by 2. Why you are writing N is equal to 1 by 4? This 1 by 4 and 3 by 2. 1 mole on dissociation, how many moles of products are formed? How many moles of products are formed? 1 by 4 mole of P4 is formed and 3 by 2 mole of H2 is formed. So LCM will be 4, 1 plus 3 to 6, that is 7 by 4, that is equal to 4 1s 4, 7 4s 28, 7 5s, so 4 5s 20, 1.75. So we got N value. N value is equal to 1.75. Then what you need to calculate? We want to calculate D. What we need to calculate? Small d. After 40% is dissociation, what is its vapor density? And we know the formula. First of all, we have to calculate D, capital D. So vapor density D before dissociation. Before dissociation, who is present? Only pH3 is present. So what is the molecular weight of pH3? That is equal to 31 plus 3, that is equal to 34. And we know that before we have discussed that to molecular weight, vapor density, what is that? Vapor density to 2 is equal to molecular weight. Okay. So now vapor density is equal to molecular weight by 2. Molecular weight is how much? 34 by 2, that is equal to 70. So we know D, capital D, then we want small d. Already we know the formula. What formula do we know? D by D is equal to, right, alpha into n minus 1 plus 1. Now D is equal to, what you can write, D by, okay, alpha into n minus 1 plus 1. So D is equal to, capital D is what? 17 by alpha is, already we have seen, 0.4. Number of moles 1.75. 1.75 minus 1, okay, plus 1. So D will be equal to 17 by 0.4 into 1.75 minus 1, how much? 1.75 minus 1, 0.75, 0.75, okay, plus 1. So D is equal to 17 by 0.4 into 0.75 will be 0.3, right? 0.3 plus 1. So D is equal to 17 by 1.3, that is equal to 13.076. We'll get this answer. Okay. So what is asked? Question, in the question, what is asked? Calculate the vapor density of phosphine at 300 Kelvin and 2.5 atmosphere when it shows 40% dissociation. pH3 has undergone 40% dissociation. Okay, to attain equilibrium. So equilibrium vapor density is asked. That is what we have calculated. Hope so you understood well. Every point I mentioned, every small concept I mentioned. Okay, right? Next, let us see some questions on this vapor density. In the dissociation of N2O4, question number 1. In the dissociation N2O4 on dissociation gas gives rise to 2NO2 gas. Okay. So with vapor densities as ratio D by D is given by, so 4 graphs are given, and 1 plus x. X is nothing but degree of dissociation. Degree of dissociation. Now from this, what we can write? N value. So N value is equal to 2 because 1 mole is producing 2 moles. So N is equal to 2. And we know the formula, D by D is equal to alpha, that is x, here given x into, okay, n minus 1 plus 1. This is the formula which we have derived. So D by D is equal to, n is equal to 2. So x into 2 minus 1, okay, plus 1. So D by D is equal to x plus 1. So both are directly proportional to each other. When both are directly proportional to each other, then what graph we do? X plus 1, see, 1 plus x, and what is that? D by D. What is given? Let us write larger, D by D. So both are directly proportional. If both are directly proportional, a straight line passing through the origin we get. Are you getting this? So that is the answer. Next, in the dissociation of what PCl5, X varies with d by d according to PCl5. So PCl5 dissociates to give you PCl3 plus Cl2. All are in gaseous form. Okay. So 1 mole PCl5 produces 2 moles of products. 2 moles of products. Then what I can write? N is equal to 2. N is equal to 2. So d by d and x, the graph. Now we have derived that d by d is equal to, okay, x into n minus 1 plus 1. Okay. Then what do you write? D by d, PCl5, dissociation of PCl5, x varies with d by d. Okay, this is equal to x plus 1. Detail, let us write it detail. X into 2 minus 1, okay, plus 1. So d by d is equal to x into 2 minus 1, x plus 1. Okay. On y-axis, what did he take? This is y-axis. Let us consider this as y-axis. This is a x-axis. Then what I can write? D by d minus 1 is equal to x. Or either I can write x is equal to d by d minus 1. Or I can also write this as x is equal to 1 into d by d minus 1. Y is equal to mx plus c. Mx plus c. Okay. So as y is equal to mx plus c, let us see here. X-axis what is taken, y-axis what is taken? X. So y-axis x. This is x, right? And x-axis what is taken? D by d. X-axis what is taken? D by d. So what is the slope? Positive slope. So positive slope means always how we get it as in this way. Positive slope. Theta is less than 90. Positive slope. Okay. So positive slope, where is positive slope? In 1 and 2. And what is the intercept here? Intercept is negative. What is that? Intercept is negative. Intercept negative means the graph must intersect on negative y-axis. What is that? It should intersect on negative y-axis. So the graph must be like this. The graph must be like this. If you extend this graph, it must intersect on negative y-axis. This is positive y-axis. This is negative y-axis. So it is intersecting on negative y-axis. Negative y-axis. So here it is intersecting already in positive y-axis. But here if you extend this, it will intersect on where negative y-axis. So the answer will be second option. Understood? Here in the first question also, see, let us take x plus 1 is equal to d by d. This can also be written as x plus 1 is equal to d1 into d by d. Y is equal to mx. No intercept. Okay. Y is equal to mx. So in this y is equal to mx, On y-axis, what is taken? 1 plus x or x plus 1, x plus 1. On x-axis, what is taken? D by d. Then they are directly proportional. So straight line passing through the origin. Understood? Understood? Okay. Let us see the next one. So next question is here. Before equilibrium is set up for the chemical reaction, N2O4 gives 2NO2. Vapor density D of the gaseous mixture was measured. If D, capital D, is theoretical value of vapor density, that is before dissociation, variation of x and d by the graph. What is the value of d by d at point A? So this is point A. Let us take. That's the point A. So graph is drawn between x and d by d. So let us derive it. We know that d by d is equal to, okay, d by d is equal to, we know that it is x into n minus 1 plus 1 degree of dissociation. So for this degree of dissociation, N2O4 gaseous gives rise to 2NO2. What is N value? N value is equal to 2 because 1 mole is producing 2 moles. So I can write it as d by d is equal to x into 2x plus 1. Okay. So what is the value of d by d at this point A? At this point A, x is equal to 0. X is equal to 0. So d by d is equal to 0 into 2 plus 1. Did you understand this point? X is equal to 0 at this point. See, this A at A means 0, no? This is 0. So d by d is equal to what? 1. So the answer is third option. Okay. Understood? So that is all with this the relation between vapor density and degree of dissociation. So let's wind up this session and we shall meet in another class with a new topic. Okay, right. Thanks for watching.